Hi, Mr. Unkert here, and in this video we're going to find the modulus, which is the absolute value of the complex number z equals 2 plus 3i. This is the distance the complex number 2 plus 3i is from the center of the complex plane. So let's start working this out. So we want to find the absolute value of z, okay, which is the distance z is from the center of the complex plane. So we're going to use the distance formula. So we're going to take this value and subtract the center. So 2 minus 0 squared plus, then we're going to take this value here and subtract the center. So 3 minus 0 squared. Okay, so 2 minus 0 is just 2. So we're going to get 2 squared plus 3 squared which is going to be 2 squared is 4, and 3 squared is 9, so we're going to get 4 plus 9, which is just the square root of 13. So the modulus of z is going to equal the square root of 13, and you can't simplify that any further from that point. Okay, so that was finding the modulus of 2 plus 3i. Hi, in this example, we're going to find the modulus, which is the absolute value of the complex number z equals -6 minus 5i. Okay. So the modulus of z is going to equal, well, we're going to use the distance formula from this complex number to the center of the complex plane. So we're going to take the real value, -6, and subtract 0, and square that, plus, we're going to take the imaginary value, which is -5, subtract 0, and square that. Okay, so anything minus 0 is itself. So we're going to get -6 squared plus -5 squared -6 squared is 36. And 5 squared is 25. If you add 36 and 25 together, you're going to get 61. Actually, let me write that up a little bit better. That didn't come quite out as good as I wanted. So you're going to get the square root of 61. Okay, so the modulus of -6 minus 5i will equal the square root of 61. That can't really be simplified any further, so you're going to leave it as is. Thanks for watching this example of finding the modulus of a complex number. Hi, Mr. Unkert here, and in this video, we're going to find the argument of the complex number z equals 3 square roots of 3 plus 3i. Okay, so first off, let's figure out where 3 square roots of 3 is, and I'm going to take out my calculator here, and I'm going to do 3, and then I'm going to take the square root of that. That's 1.732, and I'm going to multiply that by 3. So that's about a little over 5. Okay? So that'll help me to draw this number. So this here is a little over 5. Okay? So actually let me do a straight line here. So we'll draw the vertical axis, which is your imaginary axis, the horizontal axis, which is your real axis. And we'll just kind of take a look at where this number is. Okay, so a little bit more than 5. We're out to 6 there. This one's going to be at 3. So we're going to be a little bit more than 5, so somewhere right around here is my complex number. Now what they want me to find is going to be this angle from the positive real axis. So let me highlight that in a light color, see if that shows up. So from the positive real axis right here to this line segment connecting the center and the complex number here, that is going to be your argument, okay? So this angle that's formed here, that's your argument, which we can abbreviate as arg-z. Okay, so arg-z is going to equal, well, let's see what we got. So we've got the opposite side here. That's going to be, so this opposite side is going to be 3 units. And then this adjacent side here, that's going to be 3 square root of 3 units. So we can find the angle using inverse tangent by using the opposite over the adjacent. So we're going to take the inverse tangent of the opposite 3 over 3 square roots of 3. And we can simplify that a little bit. The 3's will cancel out, so you're going to get the inverse tangent of 1 over the square root of 3. Okay, so let's take this calculator back out. And okay, we're going to do 1 divided by the square root of 3. Okay, and then we're going to take the inverse tangent of that, and we'll get 30 degrees. Okay, so the argument of z is going to equal 30 degrees. We also might want to write that into radians. So we could say the argument of z in radians. And to do that, let's convert this to radians. So we're going to do 30 times pi over 180. These are degrees. Okay, so cancel this out right at 1, cancel this out right at 6. So it becomes pi over 6 radians. So that's another way to write the argument, as pi over 6 radians. And I hope that helps you to find the argument of a complex number. Hi, Mr. Unkert here. In this example, we're going to find the argument of the complex number z equals 4 minus 4i. So it first helps to figure out where that number is. So I'm going to draw a real axis here and my imaginary axis here. And 4 minus 4i is going to be right around here. Okay, so the angle that we're looking for is actually going to be the angle from the positive real axis to the line segment from the center to the complex number. Okay, so we want to find this angle, and we could call that theta. And a way to do that would be to first then find this angle, let's call that phi, and subtract this angle from 360. And that will give you this angle, because it's 360 degrees all the way around. So if we find this angle here, subtract it from 360, we'll get what this angle is up to here. Okay, so our angle phi is going to, well, let's form a triangle here. Actually, let me undo that for one moment. Form a triangle here. So we know that this side of the triangle is 4 units. This side of the triangle is also 4 units. So phi is going to equal the inverse tangent of the opposite, over the adjacent, or 4 over 4. So it's going to equal the inverse tangent of 1. So the inverse tangent of 1 is equal to 45 degrees. So as a reminder, the angle we're looking for, we'll refer to that as theta, is going to equal to 360 degrees minus 45 degrees, which is going to equal 315 degrees. We may also want to find the argument in radians, so it's best to convert this angle first to radians and then subtract it from 2 pi, because it's 2 pi radians all the way around. So to do that, we're going to take 45 degrees and multiply by pi over 180. Okay, so 45 degrees goes into 180 4 times. So I can write that as pi over 4 radians. Now that's this angle here, so theta is going to equal 2 pi minus pi fourths. So that's going to be 7 pi fourths. So you can either express the argument as 315 degrees or as 7 pi fourths. Now remember, we could write it as arg z, like this. That equals 7 pi fourths in this particular case. Just touch that up a little bit. Okay, so arg z equals 7 pi fourths. Thanks for watching. If you have any questions, please leave comments in the comments below. Also, if you like this video, please like and subscribe, as it really helps the channel, and have a great day. Bye.